on this. Sure. All right, a couple things I want to kind of draw your attention to is on Friday. At some point during Friday, I sent out an announcement that basically said any missing work will become zeros starting on noon. I was going to start changing those, and I didn't until Sunday evening. So your grade in Canvas may have changed significantly since Sunday evening, because any missing stuff is a zero. And that'll be the trend from here on out. If it's not turned in by the due date, it'll become a zero, and it's going to affect your grade accordingly. So keep an eye on those. So how do you know if you have something missing? You go to Canvas, you click on grades, and as you scroll through the list, there's these red words that say missing. That means it's missing. You haven't submitted that. Some of your submissions, you have like an NE that you say, why did I get an NE? I turn this in. Click on that assignment, blue word, submission, and rubric. It'll open up your document, and then I may have written on it with some feedback, or you want to click the next button over that says comment, and then I probably gave you some written feedback as to why. It may be just a submission error. If someone in one of my classes, they turned in a picture of a drawing of a toothbrush that I'm assuming was for an art class. It was very well done. However, that wasn't the science assignment that I was asking for. So that was an NE with a comment that went along with it. So take a look at those, figure out what you're missing and why they are what they are, and then let's take care of those things sooner than later. So great. Position versus time graphs. I want to recap position versus time graphs, and then we're going to talk a little bit, recap, velocity versus time graphs. And then I have a quiz that I'm going to have you kind of work through. So, position versus time graph. Position versus time graph. What is the slope? This is measured in meters. This is measured in seconds. What does the slope of a position versus time graph give us? The velocity, right, the change in velocity. So this is velocity. So if you have a line that looks something like that, we can go through and we can draw a fair amount of conclusions based upon that line. So slope is velocity. So is this object moving?
Yes.
Because it has a slope that is not zero, right? It's got some slope, so it is moving. The other way you could look at this is it's got some position right there. We could just pretend that it's 1 meter away, and over here, it's 3 meters away. So it starts here and it ends here. It moved in order to get 3 meters away from that reference point. So it moved, yes, it's moving. Right? Is this slope constant or changing? It's a straight line, so is it constant or changing?
Constant.
Constant. So what does that tell me about my velocity?
Constant.
My velocity is constant. And if we have a velocity that is constant, that tells us our acceleration is 0, which means my object is not accelerating. The inverse of that would be true if my velocity is changing. We could say my acceleration does not equal 0. It's any value except for 0. And we could say it is accelerating. So because my slope is constant, that means my velocity is constant, means my object is not accelerating, or we could say the acceleration is 0. Is this a positive or negative slope? Positive, good, positive slope, which means it has a positive velocity. Point which direction, if we're talking about the x coordinate system, point to which way an object is moving if it has a positive velocity in the x direction. That way. Okay, it's that way. So that positive slope, the positive velocity, tells me the direction. Okay, and in this case, it's a positive velocity, which means it's moving in the positive direction. So hopefully you realize that if we had a negative velocity, it'd be moving in that direction. Slope is constant, therefore my velocity is constant. It's a positive velocity, so it's moving in the positive direction. happen. Okay, so if my velocity is constant, then my speed is gonna be staying the same. It's not speeding up, it's not slowing down. What if we had a line that looks something like that? Slope tells me velocity, keep that in mind. So is my slope constant or changing? I'm sorry, let's take a step back. Is this object moving or not moving? Does it stay at 3 meters the whole time, or does it move? It moved, right? It ended at 1. You can look at it that way. Or you could say the slope is not 0, right? The slope does not equal 0, which means the velocity does not equal 0. So it has some number. It's just not 0, which means it is moving, or it does have a velocity. Okay, is this slope constant or changing? Curved line, changing. Okay, so curved line, slope is changing, which means my velocity is then going to be, is it constant or changing? Let's go with that.
Changing.
It's changing, right? So my slope is changing, my slope and velocity are the same, or interchangeable, so my velocity is changing. So because my velocity is changing, then that tells me my object is accelerating, or my acceleration is not 0. It has some number that's not 0 associated with it. Is this a positive or negative slope?
Negative.
Negative slope. So which direction is this object moving? In the x direction. Point to it. This way.
This way.
Negative velocity. What if we were talking about the y direction? We haven't really talked y direction, but if it was a negative velocity, it's just moving downwards. That's all that's going to be. Is this speeding up or slowing down? Because we said the velocity is changing, is accelerating, so is this thing slowing down or speeding up? And in order to look at that, we look at the slope of that line, and we look at the slope of that line. If I make up a number and say that this has a slope of -1, what is the slope of this one? Is it bigger than 1 or smaller than 1? Ignore the negative number. Is it bigger or smaller than 1? Bigger, right? So we're going to say it's, I don't know, 4. Is it a positive slope or a negative slope? This blue line right here. It's still going to be negative. What does the negative slope tell me? Tells me the direction. Tells me it's moving that way. So it was moving 1 meter per second that way, right here. Now it's moving 4 meters per second that way. Is this thing speeding up or slowing down? Ignore the sign. The number is our speed, because velocity is speed with a direction. So the number is speed, so it went from 1 meter per second to 4 meters per second. It just happened to be increasing in the negative direction. It's speeding up in the negative direction. It's going faster that way. That's all that's saying. I forgot to take attendance, so I should take that while I'm thinking about it. Okay, questions about position versus time graphs? If we look at a velocity versus time graph where this value is 0, that's my velocity, my 0 velocity. What does the slope of a velocity versus time graph give us? What's the slope of a velocity versus time graph give us?
Acceleration.
Thank you. Tells us the acceleration. It tells us the acceleration. So what if I had a line that looked like that? What's the slope of that line? 0. So what is the acceleration of that object? Is that object moving? Yes. Okay? And you could say, well, you said the acceleration is 0, right? But an acceleration of 0 just means it's constant velocity. Doesn't mean no motion, it just means constant motion. So if we were to make up numbers and say this is like +1, this is +2, this is -1, this is -2, the value is 2 meters per second in the positive direction. It's going 2 meters per second that way. It's going 2 meters per second, 2 meters per second, 2 meters per second, 2 meters per second in the positive direction. It is moving because it's not at 0 meters per second. This is 0, 0 means not moving for velocity, and it's not there. So therefore it is moving, and it's just moving in a positive direction. It's moving in a positive direction. So it's moving to the right. Okay, but we said that my slope is acceleration, so we can say that my acceleration is 0, which means my velocity is constant. We can say that my velocity is positive because we read it off that one. I want that one. Let's go look at that one. Okay, is that object moving? Yes or no?
Yes.
Yes, it's moving. How do we know velocity is not 0, right? It's below the 0 line. It's not at 0. It's getting close to 0, but it's not at 0 yet. Positive velocity or negative velocity?
Negative.
Okay, so which direction is it moving? Is it moving that way or is it moving that way? Which direction? Is it positive or negative velocity? We said this is 0. What's the value right here, right here, right here? Is it positive or negative velocity?
Negative.
It's negative, so that means it's moving that way. Now, a common thing that people look at is they look at the slope and they say, hey, that slope is positive, true statement. So they say, hey, that thing's moving that way. No, the slope is that way. The acceleration is that way. But my velocity is negative because it's physically below the line, and negative velocity means it's moving in that direction. Moving in that direction. So this is, it's moving. It has a negative velocity. Is my velocity constant or changing? It's changing, right? It was, say, -3, now it's -2, now it's -1, and now it's getting pretty darn close to 0. Is this object speeding up, slowing down, or staying the same speed? Which one is it? Is it going faster, slower, or staying the same? Slower, right? So if right here it was -3, right here, it's -1. If right here it's -0.2. Remember, the negative tells me the direction. If we're talking about the y direction, it's saying it's moving to the left. I'm sorry, the x direction. It says it's moving left. But it was going, and the number is the speed, so it was going 3, now it's going 1, now it's going 0.2. It's slowing down. It's getting closer to this 0 mark. What about this one? Is that speeding up or slowing down, the red line? Slowing down because it's getting closer to the 0 mark. Now, what we had here is we had this one down here. We had a negative velocity and we had a positive acceleration, which then when they're in opposite directions, we get slowing down. Or we could say, hey, it's physically here. This was a positive velocity. Oops, positive velocity with a negative acceleration because of negative slope, which means it's slowing. Yeah. Okay, so when they're in opposite, with my acceleration and velocities are in opposite direction, we slow down. However, if we had a line that looked like this, Then we have a positive velocity with a positive acceleration. This thing is getting fast. Okay, so there's lots of different information that we can pull from these graphs. And I hope we're pretty okay with that. Any questions I can answer about velocity time graphs or position versus time graphs at this point? Okay, then, I had said that there were 3 sheets on the back table. If you wanted to grab the 3 sheets, you should grab the 3 sheets. If you don't want a paper copy, you want the electronic version, they are all posted in today's personal agenda. The next thing I want you to work on is I want you to work on the progress quiz. I'm trying to remember what it's called, 2.01, I think I called it, something like that. Okay, I want you to work on that progress quiz. I would like you to take it first without this. Do as much as you can as possible without using this sheet as reference. When you hit that point, say, I can't do anymore, then pull this out for reference. If you get all the way through it without using it, then pull this out and use it for reference and check. Okay, that's the next thing I want you to do is work on that progress quiz 2.01. If you're joining us virtually, hit pause and we'll come back in a little bit. And then we'll go through this kind of together. So, after you've taken the quiz, let's spend some time going through this. So, if we look at this, this is velocity versus time graph. Remember, this is 0. And is this object moving? The answer is no, because there is no value above nor below the line. This object is not moving. Oh, sorry, I skipped it. Slope of velocity versus time graph is always going to give you the acceleration. Velocity versus time gives you acceleration. Position versus time gives us velocity. This object is not moving because there is no value in the y-axis above or below the line. Is the velocity of this object positive, negative, or 0? It is 0 because there is no value above or below the line. There is no values posted on the y-axis. However, the velocity is constant. It's not changing. It's just 0, 0, 0, 0, 0 the whole time through. There is no slope because there is no line, but it's a flat line. I guess you could actually plot it and it would be like superimposed over that line. So we could say that the slope of this line is 0. So because the velocity is constant, the slope is 0, we can also say the slope of this line is constant. Because the slope is 0, the acceleration is 0 because slope is the acceleration. So my slope is 0, my acceleration is 0. And if we say that my velocity is constant, we say my velocity is constant, and we can say my object is not accelerating, and then we can move on. Questions on that one? Okay. Velocity versus time graph. The slope gives us acceleration. Is this object moving? The answer is yes, and we know that because it's above the line. Okay, it's not at 0. So because it's above the line, it has a positive velocity, which means if we're talking the x direction, it's moving to the right. Okay, the velocity of this line is constant. It's a flat line, it doesn't change. It's a constant velocity. Okay, if whatever that number is, if it's positive 2, it's positive 2 the whole way. Positive 2, 2, 2, 2, 2, it's a constant velocity. The slope of this line is 0, it's a flat line. The slope of this line is constant. It's not curved. Notice how I haven't given you any curved lines? It is possible to have a curved velocity versus time graph. And in fact, that's really what most things really are in life. Like if you think of you accelerating from a stop sign to the speed limit, you're going 0. You step on your gas, you increase speed relatively quickly, and as you get closer to that 25 miles per hour, you go 0 to 5 really fast, you go 5 to 10 maybe not quite as fast, but when you get to like 22, you're starting to slow down, you're going 23, 24, because you don't want speed, right? We're good law-abiding citizens. So we would get a very curved graph that would plateau, and it would start something here, and it would kind of level off. Okay, so in real life, we get curved velocity versus time graphs all the time. The reason why we focus on constant, straight velocity versus time graphs, whether angled or not angled, is the math we have to do in order to solve velocity or constant velocity problems versus non-uniform accelerations. So a constant, I'm sorry, I said that wrong. A constant acceleration or a uniform acceleration, we can use algebra to solve. Where if we had curved velocity versus time graph, it's a varied rate problem, and then we have to do calculus, and I don't remember if it's integrals or derivatives. Either way, it's calculus, and we don't do calculus. So that's really why we focus on these linear velocity versus time graphs. But in real life, realize that's not always the case. I don't remember where I was. Velocity is constant. The slope of this is 0, it's flat line. The slope of this line is constant. So because the slope is 0, my acceleration is 0. Because my acceleration is 0, it's not accelerating. Or we could say my velocity is constant, therefore my acceleration is 0, and because my velocity is constant, the object is not accelerating. There's a couple different ways you could approach that one. Yeah?
I think your camera stopped recording.
No battery. It's recording now, but I don't know how long it's going to be recording, and I don't know what I missed. So if you missed my explanation, it was amazing, but we're moving on. Okay, hopefully you can get the answers. Thank you for telling me that, Manny. Let me know if that was, I think, 10%. It might warn me again here in 5. So, let me. Graph 3, okay? Slope of velocity versus time graph gives me acceleration. That's like the same thing over and over. That's by design. I'm trying to reinforce that idea. Plug this in. All right, is this object moving? The answer is yes, this thing is moving. How do we know? Because the velocity is not at 0. It's either above or below. In this case, it's above. Yes, it's moving. The velocity is positive. We know that because it's above, which means it's moving that way. It's moving to the right. Velocity is changing. It's at 1, now it's at 2, now it's at 3, now it's at 4. It's changing. It's not flat. It's curved. I'm sorry. It's not 0. The slope is not 0. The slope is positive, which means it is accelerating and has a positive acceleration. The line is constant. The slope is constant, which means we have constant acceleration. The object's acceleration is positive because the slope is positive, therefore the acceleration is positive because the slope is the acceleration. This object is accelerating because my velocity is changing, or you could say because the slope is not 0. The acceleration is constant, it's a straight line, which just means we can do algebra. And this one's speeding up because it's getting further away from the 0 axis, therefore the value of that speed is getting bigger and bigger. And it's getting bigger in the positive direction. Last one, slope gives me acceleration. Yes, this object's moving because it's not at the 0 mark. The velocity is 0. Common mistake people say is they say this one's positive, but the velocity is negative. The slope is positive. I agree with that. The slope is positive, but the velocity is negative. And the reason we know the velocity is negative is it's below the line. This is 0, this is -1, this is -2, this is -3. It's below the line. It's a negative number. My velocity is negative, which means it's moving in the negative direction. That's all it means. It's moving in the negative direction. My velocity is changing. The slope is positive, which means my acceleration is positive. My slope is constant, which means my acceleration is constant. And because my velocity is changing, we can say this object is accelerating. Or if we say my slope is not 0, or we say my acceleration is not 0, right, because it's positive, some positive number, then we can say, yes, this object is accelerating. Straight line just simply means, this constant acceleration means we can do algebra, but this object is slowing down because it's getting closer and closer to the 0 mark itself. Now what could happen is if we were to extend this line, keep going, what would happen is it's going in the negative direction, it's slowing down, it stops, and if it continues on, then it's going to be going this way, it's going to stop, and then it's going to turn around and accelerate back in the positive direction. It's possible. I've been very purposely choosing graphs that don't cross the zero axis. Questions on that? Okay. So what, again, I have 2 Socrative quizzes posted in tomorrow's virtual to-do list. There's 2 separate room names that you are to go through and enter. One is for velocity versus time graph, one is for position versus time graph. I do say that you are welcome, you read the instructions because there's some helpful tips in there. One says that you're allowed to use your pink sheet. One says you're allowed to take it twice if you so choose. You need to submit both of your screenshots. I want a screenshot. It'll make my grade entry a lot easier. However, it does dump it into like a database that I can actually pull that from, and I will be randomly choosing some to just double check. So that's tomorrow. Final questions on position versus time or velocity versus time graph. Okay, then let's take a look at that yellow sheet, that little half sheet that you picked up on the way in. On the back side, or I don't know which side the front, which side the back. On the side that has the data table, let's take a look at the data table. So on the data table, there are a series of variables that we use. And it says knowing these variables will be helpful to identify what numbers, so this is called Fab 5 equations. And on the back side, we have this. So we have these equations that we call Fab 5. There's 5 of them. They're fantastic. They're fabulous. Therefore, we call them the Fab 5. So all of the equations on the other side of this have these variables in some format listed. Delta x or delta y. I'll come back to the delta y. VI, VF, V average, A, and a T. So what the heck do these all mean? Well, delta x is displacement, velocity, acceleration, time. Those are really the 4 things. This is a vector quantity, so it has a direction. Vector has a direction, acceleration vector has a direction, time is scalar, no direction. Can't go back. You can't say ready, set, go, and that's time 0, and then go back in time 10 seconds because your time frame didn't start yet, so it's a scalar quantity. The units we measure everything is, I have in parentheses, that's just like our shorthand notation, like we use M for meters, meters per second squared, or sometimes it's written meters per second, which not a whole lot of people use, but it is there sometimes, or it's meters / seconds / seconds. But most of the time we do those quick algebra to go meters per second squared, and time is measured in seconds. Now, delta x is how far does this object move in the x direction. And all of our equations on the other side only have a delta x. But when we talk about 1D motion, things are either moving in the x direction or the y direction, one or the other, for now, when we talk 1D. And the equations on the front are only written in terms of delta x, but all we have to do is substitute a delta y when we're talking about vertical things. That's the only difference. Now, for v's, there's 3 different types of v's, or velocities. There's a VI, VF, and V average. So average velocity is like average speed. It's that total displacement you went over a given amount of time. It was the Cannonball Run example of they went from New York to LA. Their total average speed was blah, 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 140 some miles per hour, 39, I don't remember what it was. Okay, we don't use that very often. We very seldom solve for average velocity. VI and VF just stand for initial velocity and final velocity. So when we talk about a period of time, what do we start with? That's my VI, that's my initial velocity. VF is my final velocity, and what it's ending up with. A is acceleration, and T is time. So we're going to be doing story problems almost from here to the entire end of the school year now. When we do our physics, they're really just problems, or story problems kind of stuff. So when we're solving for particular variables, we got to kind of use some wording to kind of figure out what they're asking for. So these are some kind of generic forms that we might be asking. So if they say like, how far does a car travel? They're asking us to solve for like delta x. How far does an apple fall? We're talking about delta y. If we're talking about velocities, it's like how fast. Acceleration, we're not super creative. We say like, what is the acceleration required, or what is the acceleration of an arrow? I don't know, whatever. In time, we can measure. They might ask the question of how long. Now, you got to be a little bit careful and kind of read the context a little bit, because we can measure distance or displacements with how long. Like how long did the How long did it take? No, that'd be time. We can measure distances with like we could ask the question like how long is this table, right? So you just gotta be a little bit careful. How long does it always mean time? It could mean displacement. Okay, so when we flip this over, these are the equations that we use. We call these the Fab Five. And out of convenience sake, we often number these simply as equation number 1, equation number 2, equation number 3, equation number 4, and equation number 5. And the reason for that is simply when we go through and say, hey, what equation you want? Or what equation you can use? Or what equation did you use? You can say number 1 or number 2 or number 3. I'm like, ooh, you should have used number 4. Instead of having to say, oh, you should have used VF squared is equal to VI squared plus 2A delta X. I'm gonna go like that under equation number 1 because we barely ever use equation number 1. We barely use equation number 1. We used equation number 1 when we did that worksheet called speed problems. That's probably the most we're gonna use it all year. There's occasionally a problem or two. The only time we would use equation number 1 if they very specifically said, what is the average velocity? Or if they were to say, is moving with an average velocity. But almost never do they ask that. Normally we're saying, how fast was a car going when it started? How fast was it going at the end? We're looking for things like that. And when we solve these equations, let me just get this and then we can be. When we go through and we set these up, I go through, I read a problem, I'm circling and I'm looking for numbers, and I'm using these units, these meters per second, these meters per second squared, these seconds, to help me identify what variable each thing is. So part of my problem solving method is I go through and I make a list of variables, and I always make my list of variables in the exact same order, just out of convenience. So when I do a problem and say, hey, this thing's moving the X direction, I'm gonna make my list of variables, delta X, VI, VF, A, and T. And then what we're gonna do is we're gonna put numbers in there that match. So if it was something like 15 meters, I could say, oh, meters was the delta X, and this is gonna go here. Now the only kind of change to this is sometimes I have a delta Y. So it'd be delta Y, VI, VF, A, and T. And all of these equations over here that have a delta X, we can very easily substitute a delta Y into. Okay, so that's where we're gonna leave it for today. I'm going to write that because there's a few more things we need to do. So that's where we're gonna leave it for today. There's 2 quizzes for you to work on. Each quiz is 20 questions long. Just realize that it's like this, it's the same graph that we ask different questions for like 5 times, 4 times. So, you know, it might be, this is your graph, and say, is this object moving? Yes or no. Is my velocity constant or changing? Yes, you know, pick the right one. So we might ask like 4 questions on the same graph. Just look at the graph and answer the questions accordingly. If you have any questions, send me an email, let me know. Have a good day.